Hey everyone. I wish we could all be in Brussels right now, hanging out at the Delirium Cafe, drinking amazing beer, and chatting about open source and technology. But I'm hoping that you're all safe and healthy. And one positive is that I can show you a bit of where I live, Portland, Oregon, USA. So the other day, I was driving in my partner's car, and a light came on the dashboard. Now, normally these lights tend to be fairly useless, but the one thing that I love about my partner's car is that it has this little message display. And oftentimes the messages are extremely useful. It'll say, for example, it's time for regular maintenance when you need an oil change. So this time, a message came up and it said, "See manual." My partner's extremely organized, so the manual was of course in her glove box. So I reached over and I pulled it out and I looked at the table of contents. And I realized that "See manual" wasn't very useful. How many times have you gotten an alert? Something's gone wrong in your system, but the alert didn't have the information that you needed to actually solve the problem. Or maybe you went to a dashboard and you looked at the graphs and the graphs showed that something was strange, but it didn't provide the context to know how to diagnose the issue, let alone fix it. So from there you turn to the documentation, only to realize that there's not enough documentation. You don't know what's gone on. So inevitably you end up escalating these problems and you make them somebody else's problem. So how do we make things better? First, we need better alerts, and that requires two things. Alerts need to provide context and action steps. Context. Why did this alert get triggered? This seems obvious, but in my experience, people often conflate what they think is wrong with what actually triggered the alert. For example, an alert might say, "Critical, service down." But actually, the service emits a heartbeat every 10 seconds, and the heartbeat hasn't registered in the past 30 seconds. Our monitoring is usually a proxy for the things that matter to the business. Knowing the difference is critical context when you're trying to troubleshoot things. So be very clear when communicating why an alert was triggered. The second piece of context is, why is this important? How does this issue affect the larger goals of my team or the company? This context allows me to prioritize and potentially develop mitigations. If the missing heartbeat indicates that a service may be down, I need to know what impact that has on my customers and business. In addition to context, alerts need to provide action steps. What dashboards do I need to look at? What runbooks or documentation do I need? And what specific sections or action plans within those should I reference? And also, who can I escalate to when necessary? But alerts are a small part of the problem. In my time at Datadog helping thousands of customers, it was clear that many dashboards are useless because they're too busy. They have graphs of everything, and 90% of that information is useless. Or worse, it's completely misleading. We do this because we like to make dashboards look cool. But here's the secret. You shouldn't be constantly looking at dashboards. When you're driving a car, you watch the road. You watch the road ahead you and you don't stare down at the dashboard. It's only there to validate your operating parameters. Like when there's a change in speed limit, you verify that you're driving the correct speed. So don't design your dashboards to look cool. Design them for troubleshooting. This means two things, and it's really easy to remember. It's the exact same as your alerts. Dashboards need context and action steps. Context means you need to name your metrics well. I've seen so many dashboards where it's unclear if CPU was system CPU or service CPU, and was that CPU available or consumption? Inevitably, it was always the opposite of whatever the on-call engineer thought it was. If you're not sure how to name metrics, I love the guide that the Prometheus community has published, so reference that. More context. Your dashboards should tell the viewer what information it's providing. What service is this for? How does that service relate to your other services? Where are the dashboards for those other services? What are the common ways that this service can fail, and how would I validate that on the graphs that are being shown? This probably means that you need to add more text widgets to your dashboards. And those text widgets are also useful for providing action steps. If I'm seeing abnormal behavior in these graphs, what should I do to further investigate or resolve that problem? Where can I find additional documentation? This advice, however, is just best practice monitoring. But how do we do proper monitoring? And what do I even mean by that? Monitoring is usually bespoke. It's an artisanal act of handcrafting dashboards unique to each service. Proper monitoring means we need to adopt practices of modern software engineering. Proper software development requires documentation, revision control, and testing. These are things that we've now implemented with infrastructure as code. Our infrastructure now has documentation, revision control, and testing. And we need to do that with monitoring. We've already discussed your dashboards and documenting your dashboards with context and action steps. So let's talk about revision control. Store your dashboards and alerts as code. Yes, you can build them in the GUI, and that's a great place to do that, but export it. Put that into Terraform or Chef or Ansible, whatever you use. But you can now revision that code. Or even better, you can treat it like open source and share it with the community on places like the Grafana community dashboards. Keeping your dashboards as code means that you can store them with your services and with your infrastructure, whatever they're related to. Finally, testing. This is where chaos engineering is most valuable. Chaos engineering isn't about breaking things. It's a process of testing your assumptions. Does that graph really show the amount of CPU you're consuming? Use a chaos engineering tool to consume CPU and verify it. And chaos engineering doesn't mean you should cause chaos. It's about replicating the chaos of the real world in a very controlled way. After you've verified that your graphs are showing the correct metrics, verify that the documentation and action steps in your alerts and in your dashboards are valid. The process is simple. Start with a hypothesis. How do you think your systems will behave? How will that appear in your monitoring, and will it trigger any alerts? Are the context and action steps in your alerts and your dashboards enough to identify the problem, respond to it, and lead to the right results? Then inject the failure and verify it. Analyze your results and keep repeating and iterating until everything works as you expect. So let's improve our monitoring by ensuring all alerts and dashboards have context and action steps. Let's ensure that they're in code and that they're revisioned, and that we share them with the community as open source whenever we can. And nothing is complete until it's passed tests, which means you need to start doing some chaos engineering to validate that everything works as you intend. I hope you all enjoy FOSDEM, and I look forward to seeing you next year in Brussels.